Welcome to Math 1314. This is section 1.6. In this section, we're going to look at a couple different kinds of equations. In the very first problem here, I have a product of three things equal to 0. Now, the only way a product of things could be 0 is if any of the pieces could be equal to 0. Alright, so I'm going to set each part equal to 0. Grab the first part. Minus 5x is 0. Divide both sides by minus 5. And I get x is, 0 over negative 5 is 0. So one of my answers is 0. Grab the second piece. 6x minus 8 equals 0. Alright. Move the 8 to the right-hand side. 6x is 8. Divide both sides by 6. And now I can reduce that number some. 2 goes into 8 4 times, 2 into 6 3 times. And so I get x is 4/3. My other piece, 7x plus 7, set that equal to 0. Move the plus 7 to the right, which makes it a minus 7. And then divide both sides by 7, and I get x is minus 1. So my solution set consists of these three numbers. All right, let's see. In question 2. So again, I've got some pieces of things multiplied together to give me 0. And so I want to set each of the pieces equal to 0. Now, only these two pieces have variables in it, not this one. Minus 8 is always minus 8. Minus 8 could never calculate to be 0. So there's no need to set that piece to 0. You're only setting to 0 parts that could calculate to be 0. Let's see, the first piece, t squared plus 10 is 0. Move the 10 to the right-hand side. T squared is minus 10. And now we use the square root property. Take the square root, so plus or minus square root of minus 10. But it's a minus, and so therefore I can split off the minus 1, and that becomes an I. So I've got plus or minus I square root of 10. And square root of 10 can't be reduced any. Let's see, we also have t squared minus 7 is 0. So I get t squared is equal to 7 when I move the 7 to the right-hand side. So t is plus or minus the square root of 7. All right, so my solution set consists of the plus I, the minus I, the plus square root 7, and the minus square root 7. So there are 4 possible solutions. All right, question 3, we have something a little bit different. And I see I have 1, 2, 3, 4 terms equal to 0. Whenever you have that situation, we typically want to solve it by grouping. And I want to group this into pairs, pieces that have 2 items in it. Now, if I just jump on in here and put parentheses around the 2 items, that would be wrong. Now you say, well, what's wrong with that? Well, there's nothing wrong in this first piece, putting the parentheses there. Where the mistake comes in is if I put parentheses around these 2 parts. If you remember the way that the negative works, the negative would have to be distributed, giving me minus 2n minus 3. But my problem didn't have a minus 3 in it. It had a plus 3. So the right way to do the grouping is when I put the parentheses on the second part. I change its sign to be minus. Because then, you see, I've got minus 2n, my problem has that. A minus 3 is a plus 3, and that's what the original problem was. So when you do the grouping, you have to make sure you could get back to the original problem. So now I'm looking at my two pieces, and I'm noticing on the very first part, there's some stuff in common. I have a 50 and a 75. I can take out a 25. I've got n3, n2. There's at least an n squared in common between these two. Take it out. Okay, so 25 times 2 is the 50. 25 times 3 is the 75. N squared times n cubed, n squared times the 1 there. Yes, so that looks okay. So now, where are we at? Well, looking at this, I'm noticing the things I've got underlined in blue, they're in common as well. So I want to take it out. All right, so when I take it out, let's see what happens. I take it out in the front. If I take it out of this piece, certainly I've got left a 25n squared. Now when I take it out of this piece, there's not just an empty hole there or a vacant place. There's always this imaginary 1 sitting there, and that's where this piece comes from. When you take this out, there's still a 1 there. So finally, I've got a product of things is 0. Grab the first piece, set it equal to 0. So I move the 3. 2n is 3, and then divide both sides by 2. For this piece, let's see, I'm going to move the 1 to the right. I'm going to get rid of the 25, divide both sides by 25. And this looks like we're all set up for the square root property. And so I get n is plus or minus the square root of 1 over 25. Square root of 1 is 1, and square root of 25 is 5. And so my solution set then would consist of n is, let's see, we've got the 3 halves, we've got the 1/5, and we have a minus 1/5. So 3 solutions to our problem. Let's see, question 4. Well, looking at this, first thing I notice is I see a 4 in common. So take out the common 4. And again, when I take out this 4, there's still a 1 there. And you can check that you could get back the previous line. Now this a to the 4th is a little different maybe than what you've seen before, but it works just like the difference of two squares. A squared times a squared, a to the 4th. Plus 1 times minus 1 is the minus 1. And because of this alternation in sign, I do get the minus 1 back. So I grab the first piece, set it equal to 0, and then grab the second part, set it equal to 0. Let's see, a squared plus 1 is 0. I'm going to move the 1. A squared is minus 1. And so by the square root property, I get plus or minus the square root of minus 1, which is plus or minus I. From the second piece, a squared minus 1 is 0. Well, I'm going to move the 1 again. This time it's positive. And so I get a is plus or minus the square root of 1, but the square root of 1 is just 1. And so my solution set consists of plus I, plus 1, minus 1. 4 possible solutions. All right, now in our last problems here, we're trying to solve an equation, and this equation has variables in the denominator. That presents a new kind of headache for us. Well, the way we start this is to make sure all the denominators are completely factored. That's already done. That's nothing to do. What about this piece? Let's see. Can I split this up? Let's see. Q minus 4, Q plus 2. Q times 2Q, Q squared. From the middle, I've got a minus 4Q. I got a 2Q from there. So yes, that is a minus 2Q, and I've got a minus 4 times a plus 2 to give me a minus 8. Now, another way to look at it is it's a math problem. Things are supposed to work out reasonably nice. So my first guess on how to factor it is going to be these two pieces. All right, so now that everything is factored, I'm wondering, is there any numbers that I could plug in for Q that would make my whole problem undefined? Remember, undefined comes about whenever you have 0 in the denominator. Well, yes, if Q happened to be 4, 4 minus 4 is 0, and the whole problem blows up. If Q is minus 2, minus 2 plus 2 is 0, and this piece blows up. So, yes, we do have some bad answers, some things I don't want to get. Now, next, now that we know what's bad, we can continue onward. I need to multiply by something that'll make all pieces go away. So I'm going to pick this piece. As you see here, I'm multiplying it all the way across. Well, let's see, in the first piece, the Q minus 4 piece goes, and I'm left with 6Q, Q plus 2. Here, the Q plus 2 part cancels, leaving me 6 times Q minus 4. And on the right, everything cancels, just leaving me with the top. All right, so let's see. Next, let's distribute the things on the outside inward. 6Q times Q, 6Q squared. 6Q times 2, 12Q, 6Q, minus 24. Whew, a lot to do. Now, next, I want to try to get everything on one side. So let's see, 6Q squared. This is going to come over, so it's 6 minus 5, giving me the Q squared. What about the Q junk? Let's see, 12 and 6, that's 18Q. This is coming over from the right, so 18 minus 16 is a plus 2. Minus 24 just sits there. All right, now let's see. Can we factor this? Q times Q, yes. Let's see. 6 times a minus 4, that is a minus 24. And 6 minus 4 gives me the 2 in the middle. So now I set all the pieces to 0. So here I'm going to move the 6. I get Q is minus 6. That's okay. That's not a bad answer. Remember, what were the bad answers? I forget. Let's see. Bad answers were 4 and minus 2. So minus 6 is okay. What about this 4? Bring it over and I get Q is 4. Oh no. That's one of the bad answers. So I throw it out. I don't keep it. It was a possible answer, but it's bad. So my solution set consists of this one number, which is minus 6. Question 6. Let's see. Same situation. Nothing really to factor. It's already about as easy as it's going to get. What would be bad? What answer don't I want to get for x? Well, let's see. I don't want to get 0. 9 over 0 would be undefined. 2 over 0 undefined. So I don't want to get 0. So I want all the fractions to go away, so I'm going to multiply through by x squared all the way across. Nothing cancels in the first, so 5x squared. One of these x's go, I get a 9x. All of these go, and I get a 2. So bring the 2 to the left. All right, so now, is this factorable? Looks kind of ugly. Let's see. 5x and x is a 5x squared. I need a minus 2. Let's see, the minus 1 times a plus 2. That'll work. How do I get this 9 in the middle? Well, let's see. I've got from the outside 10. 10 minus 1, yes, that would be 9. So now I grab each piece, set it equal to 0. I get 5x is 1, or x is 1/5. From this piece, I get x is minus 2. That looks good. All right, so my solution set consists of those two answers. Let's see, what about question 7? What needs to be factored? T minus 4, that's okay. This doesn't even have a denominator. It's okay. And here, there's no numbers in common, but there is a t that I could take out. Now, are there any numbers or values for t that would blow the whole thing up? Well, pretty clearly, if t is 4, 4 minus 4, 0. 4 minus 4, 0. So I don't want 4, but I also don't want t to be 0, because 0 here, 0 times anything is still 0. So my bad answers would be 0 and 4. All right, so I go through our process of trying to cancel denominators. So let's see. Multiply t minus 4 all the way across. In the first piece, everything goes, and I get a 64. Middle piece, nothing goes. I get 4t minus 4. And on the right, t minus 4 goes, and I get a 16t. All right, let's clean this up, see what happens. 4t times t is a 4t squared. I get a minus 16t here. This is coming over to the left, so another minus 16t, and the 64 is just sitting there. So let's see, minus 16, and minus 32. And now let's divide everything by 4. Okay, that looks okay. T squared minus 8t. 64 divided by 4 is 16. Now, this factors into t minus 4, t minus 4. Let's see, why is that? T times t, t squared. Minus 4 times minus 4 is a plus 16. Minus 4, add another minus 4 is minus 8t. And so I set this piece equal to 0, and I get t is 4. But I remember something about 4. 4 was a bad answer. So we had one possible answer, but it's bad, so I throw it out. That means I've got no answers. So we get no solution. You also can think of it as the empty set, which has two set brackets with nothing on the inside.